Crooked math. All right, welcome to an SBAC quick lesson. Today we're going to focus on data and statistics. So get out your notes. We're going to take some notes, fill in our little note taker here on some statistics things. So remember, these are things that you're probably going to see on SBAC, but we don't normally get to them until after SBAC. So we're doing little quick lessons so that you've seen them and you've had some information about them and you're not maybe 100% lost on SBAC when you see these on the test. So on your information, all these vocabulary words are not filled in, so you're going to have to fill them in. So here are some statistics vocabulary. So the first thing is this word mean. Okay, the mean. All these words have to do with statistics, which has to do with data. And the mean of the data is the average. You may have found the mean before, but it's basically when you're going to add all of your numbers together and then you're going to divide by however many there are. Okay, so if you have 6 numbers, 5, 2, 1, 3, 5, okay, I would add all of these together and then divide that answer by 6 because there are 6 numbers in this data set. 1, 2, 3, 4, 5, 6, 6 numbers. So I would add all these together. So let's see, this makes 10. This makes another 10. So this is 22. And then I would divide that by 6, and that would make my mean. Okay, my mean is my average. Median is the middle value when you order them from least to greatest. Median, you can kind of think of if you've heard your parents when they're driving, they may talk about the median, which is in the middle of the road. Okay, that is your median. So if I'm looking at this data, again, this data set, if I put them in order from least to greatest, 1, 2, 3, 5, 5, 6, and then I'm going to find the one that's right in the middle. So 1, 2, oh, I have 2 that are right in the middle. So what we're going to do to find our median is we're going to find the average or the mean of those 2 numbers. So I'm going to add 3 plus 5 and then divide by 2. So 3 plus 5 is 8, divided by 2 is 4. So our median is 4 in this case. Now, if you had an odd set of data, and let's say you had a number here, maybe it was another 3, then that would become your median. Okay, so just the number that's in the middle, median. If there's 2 numbers in the middle, you find the average of those 2 numbers. All right, the next one you're going to write down is the mode. The mode is the one that is most often repeated, okay? Mode occurs the most. So I'm going to just keep them in number order, the numbers we're working with here. 1, 2, 3, 5, 5, and 6. You can find the mode because it's the number that occurs the most, and we have 5 as the most. Now, some data values do not have a mode. If you do not have a number that occurs more than once, you do not have a mode. If you have 2 numbers that occur the same amount of times, so for example, if I had another 1 here, okay, then 1 and 5 would be my mode. So you can have more than one mode. Okay, the next one is our range or spread. Our range is the difference between the greatest and the least values. You're trying to figure out like how far does my data set go from the least to the greatest, right? So if I take my highest number and I subtract my lowest number, this becomes my range or my spread. It spreads 5 digits, 5 numbers. Now, shape is an interesting one. We talk about shape not when numbers are like they are here, not when we have them ordered like they are here, but more like when they're in a graph. We look at the shape of this graph. You can see here that this graph is skewed to the left. Skewed means it's uneven, and so the shape of this graph would be skewed left because, as you can see, it's taller on one side than the other. So skewed left means that there's more on the left side, or sorry, more on the right side than there are on the left. And then skewed right would be the same thing, but opposite, okay? If you had something that was not skewed, that was evenly spread, then your data curve would look like this. We call it a bell curve, where you would have bars, if you're looking at a bar graph or a histogram, that kind of follow the same pattern. Okay, this would be more of a symmetrical data. It means that it's balanced around the mean. So this would be symmetrical, and these two things are skewed. So shape describes the type of graph, including some if it's symmetric or skewed, and symmetrical data means that it's evenly balanced around the mean. So if you haven't done so far, pause and write down everything I've highlighted. You want to make sure you put that in your note taker so you have it. If you want to add the extra examples that I did, you can do that as well. Otherwise, we're going to move on to the next data. All right, a histogram. A histogram looks very much like a bar graph, except notice that these bars touch. And then notice that the amounts under my bar graph is not just one single number. So a histogram is a graph that is used when data can be grouped into ranges. So we use histographs a lot in social studies because these could be years or ages or something like that. So this data here, this right here, this 10, means that there are 10 people between the age of 20 and 29. Excuse me. 10 people between those ages. Here, this next one says that there are 18 people between the age of 30 and 39. Do we know if they're all 30-year-olds? No. Do I know if they're all 35-year-olds? No. I don't know the spread inside the range, but in certain data, it doesn't matter the spread. We just kind of want to know the range. You can also see here, there are 0 people between 10 and 19. Okay, so histograms display frequencies of continuous data. For example, weight, height, time, age, years. Okay, but it's looking at that frequency. How often is there something in this range? That's a histogram. And you make histograms just like you make bar graphs. You would take the data. For example, if I had data here, I could say these were the ages and this was the frequency. And I could say 10 to 19 and I could have nothing there. And then I could say 20 to 29 and I could have 10 tally marks, and then you would just make the bar graphs. You just want to make sure that the lines are touching because they are this range, they kind of merge into each other, right? 20 to 29 leads right up against 30 to 39. So the bars touch. Okay, same thing, pause, write this down if you need it. All right, box plots are another type of graph, and they're a little complicated, but what you need to know is that box plots are used to compare the spread and distribution of a set of data. We're looking at, in a box plot, we're not looking at specific numbers. We're looking at where does it start, what is its minimum, where does it end, what is its maximum, where is its middle, where is its median, and then where is the majority of data located? So quartile 1 and quartile 3, think of it like this is a fourth of the data, this is half of the data, and this is 3/4 of the data. So it kind of shows us, like in this box plot right here, you can see most of the data leans towards the smaller minimum side, okay? The very middle is 30, which means that 60 is still pretty high, but even though 30 is halfway between 60 and 0, because our minimum is a little bit greater, it's a little low compared to where our graph is, right? And so you can see sometimes these box plots are called box and whisker plots because this is the box and these are the whiskers, okay? But this is showing where the majority of our data is, and then these are kind of just showing where the minimum and maximum go, okay? So minimum, maximum, median, and then quartile 1, quartile 3, or inner quartile 1 and inner quartile 3. The quartiles can be subtracted from each other, the difference between quartile 3 and quartile 1 is your inner quartile range. So in this set of data, since quartile 3 is 45 and quartile 1 is 15, I can do 45, take away 15, and that gets me my inner quartile range of 30. Now the range is just the difference between the minimum and the maximum, just like it was earlier when we were talking about range. So for the range, I'm just going to subtract the largest number, which is 60, and the smallest number, which we would have to approximate, and I would say maybe that's, about half, but maybe it's 7.5. So if I did 60 take away 7.5, I would get 52.5. And that would be my range, whereas this guy is my inner quartile range. Again, all these plots and these diagrams are different ways to look at data. We're going to talk a lot more about when we use them, but these are just the new ones that you may not have known about before. So this histogram, this box and whisker plot, and then the last one is a dot plot. Now, dot plots are like bar graphs, except you use a dot to represent each piece of data. And it's really helpful to show the spread of data and the shape of the data, because you can see here this is pretty balanced. It's got that nice curve going, but without having to draw bars or even have a side axis, because each dot represents one. Now, another thing you can do with dot plots is you can make a key that tells us maybe each dot represents 1,000. Maybe each dot represents 5. So you can represent really large numbers of data in a little bit easier way. Okay, so on a dot plot, you still have minimums, maximums. Minimums are the smallest dot, maximums is the highest dot, and then you can identify really easily the mode, the one that occurs the most, because it's going to be the tallest line. You can still find a median or middle, because I can still kind of go from side to side, 1, 2, 3, 4, 5, 6, 7, 8, and still find the one that's in the middle. But modes and minimums and maximums are the easiest. And so your median is still that middle value. They're already ordered in line, so you would just go in to find them. Dot plots are used to display the spread of data along an axis. So it's really, you use a dot plot when you really want to see, is my data skewed right or left? Is my data evenly spread? Are there any huge outliers or gaps in my data? Dot plots really help with those. All right, we don't have a lot of time left, but that's all of the information that you had to write down for notes. What you're going to do now is the rest of your packet is a bunch of questions that are these find the one that doesn't belong, which one is wrong. So you're basically looking at these 3 statements and looking at the data that's given and finding the one that is not true. So here we have a dot plot that shows the number of goals scored during each soccer game by the Warriors soccer season. And we're going to fact check each sentence. Is it true that the range of the data is 6? Well, let's see. The range would be the largest number, 6. Take away the smallest number, 0. Is 6 take away 0, 6? Yes. So we know that number 1 is true. The median of the data is 2. So if to find the median, I have to find the one in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, the median is 2. So that means that this one should be wrong. It's telling me the inner quartile range of the data is 4. That one gets a little tricky. This dot plot is not in a box and whisker plot, but basically to find quartiles, you are going to find the middle, which we found was 2. And then I'm going to find half. Where's the middle of the lower half and the middle of the upper half? Okay, so if from here I'm going to count 1, 2. So you can kind of see here, once I find this lower quartile was 4 and this upper quartile is 1, When I subtract them, I get 3, which is not 4.